All right, so we're going to continue on with, this is section 7.4, partial fractions, part 6. So this is a long section. It's supposed to take up like, I think 2 lectures worth of stuff. So last time we saw, so let me first, before I do anything, let me write down the integration formula we had last time. So the integral 1 over x squared plus a squared dx. This is 1 over a arctan of x over a plus my integration constant. So we're going to need that again here. So last time, the place we stopped was, we did a partial fraction problem with an irreducible quadratic. And we're going to do the same thing here. So we're going to do, but the difference between that one is we're not going to be left with something nice like x squared plus 4. We're going to be left with something that is irreducible and is like there's a polynomial with non-zero coefficients. So let's jump into it and you'll see what I mean. So we have an example. So we have the integral 4x squared minus 3x plus 2 divided by 4x squared minus 4x plus 3 dx. Let me zoom in a little bit, make this not so large when I upload the notes. All right, so we start looking at this and we say, okay, how am I going to do this? U substitution won't work. Can I start with partial fractions? Answer is no. I have to do polynomial long division first. The degree of the numerator is the same as the degree of the denominator. I can only do partial fractions if the degree of the numerator is less than the degree of the denominator. So let's do the polynomial long division first. So we have 4x squared, sorry, that would have been right, yeah. So the thing that goes inside the division side is the thing on top. So think about with real numbers if that confuses you. Okay, so let's do this division. So if I want to divide these two things, I ask myself, okay, what do I multiply 4x squared by to get 4x squared? This one's pretty easy. This one is just 1. If I go through and do that multiplication, if I multiply through by this polynomial, I'm going to get minus 4x squared minus 4x plus 3, just multiplying all of those by 1. And now I subtract these. So 4x squared minus 4x squared is 0. Minus 3x plus 4x is x. 2 minus 3 is 1. And now I have to stop because the degree of the remainder, so the degree of this thing, is less than the degree of the divisor. So I stop and I can't go any further. So we have that 4x squared minus 3x plus 2 divided by 4x squared minus 4x plus 3. This is going to be equal to 1 plus the remainder divided by the divisor. And now I can try and do this integral. So this is the integral that I'm left with. The integral 1 plus x minus 1 over 4x squared minus 4x plus 3 dx. Okay, so now I want to do this integral. So I'm going to split it up into 2 integrals. So I have integral dx plus the integral x minus 1 over 4x squared minus 4x plus 3 dx. And the first one is really easy to do. It's just x. The second one, so again, last time we had a really straightforward example. We had something that was of the form, it was a x squared plus 4 in the bottom. I don't have that nice form here, so I want to check if this is, so first thing I'm going to do is I'm going to check if this is irreducible. And it is irreducible. So it's irreducible because if I look at b squared minus 4ac, this is going to be equal to negative 4 squared, which is 16, minus 4 times 3 times 4. This is 16 minus 16 times 3 is 48. The point is this is less than 0. And so if I were to use the quadratic formula on this, square root of b squared minus 4ac, that's going to give me imaginary roots. So this polynomial has imaginary roots and it's irreducible. That means if I were to try, partial fractions on this, I'm going to be looking for something in the form, ax plus b over 4x squared minus 4x plus 3. And that's already the form that this integrand is in. So this integrand is already in its partial fractions form. If you try and set that up, you're just going to find a is equal to 1, b is equal to minus 1. And it's not going to help you at all. So I don't have to do any more partial fractions on this. But now the point is, I want to get this. So in the last example, I was able to do it because I had 1 over x squared plus 4. So the point is, I want to make this 4x squared minus 4x plus 3 look like something squared plus a number. To do that, we're going to complete the square. So the way we complete the square is we're going to factor, we have this 4x squared minus 4x plus 3. I'm going to factor a 4 out of the first two terms. Yeah, that works. So the idea is, I want the coefficient in front of x squared to be 1. And then to complete the square, I'm going to add and subtract b over 2a squared inside the parentheses. And in this case, b over 2a, so b is 1, a is 1, so this is 1/2 squared. Well, b is negative 1. I'm squaring it so it doesn't matter. So this is 1/4. So what I'm going to do is I'm going to do 4 times x squared minus x plus 1/4 minus 1/4, and then I have a plus 3 out here. You could have factored the 4 out of the 3 also. You don't have to do it because you're going to end up distributing it back in anyway. So this is equal to 4, and now the point is this term is a perfect square. This is x minus 1/2 squared. You can check that if you need to. And I still have this minus 1/4 here, plus 3. I'm going to distribute this 4, and I'm going to get 4 times x minus 1/2 squared minus 1 plus 3. So there's going to be a step here that I'm going to need to explain in a little more detail because it's not going to make a lot of sense. So what I'm going to do with this 4 is I'm going to write it as 2 squared. The reason I'm going to do that is because I don't want 4 times something squared plus a number. I want something squared plus a number. So I want to be able to bring this 4 inside the parentheses. But to do that, I need to write it as something squared. So I have the product of 2 things squared. This is 2 times x minus 1/2 squared. So in order to bring something inside of a square, I need to take its square root essentially. And now this is 2x minus 1 squared plus 2. And now I'm finished completing the square for this problem. So the point of that all was, I had this 4x squared minus 4x plus 3 in the denominator of my integral. I can now write my integrals. I have the integral dx plus the integral of x minus 1. The denominator was that 4x squared minus 4x plus 3. But after completing the square, this is now 2x minus 1 squared plus 2 dx. And how does that help me? Well, let's go ahead and take care of the first integral so I'm not having to write that constantly. This is x minus 1 over 2x minus 1 squared plus 2. So this isn't what I want still. I don't want 2x minus 1 squared plus 2. I want just one thing squared plus 2. So what I can do here is I can do a u substitution. I'll let u equal 2x minus 1, and then du will be 2 dx. So dx then will be 1/2 du. So let's go ahead and go through with that u substitution. So x plus the integral, x minus 1, can't really do anything with that yet. We can hope it cancels out, but we're going to see that it doesn't. 2x minus 1 is u squared plus 2. dx is 1/2 du. Okay, problem is I've done the u substitution. I still have an x floating around. So what I can do is I can use my u substitution, And in this case, I can solve it for x. So if I take this, I can solve it for x, and I get x is equal to u plus 1 over 2. So let that sink in for a minute. I know I'm going quickly through this. So you're welcome to, as I'm going through this, you can always pause the videos and catch up. So don't feel the need that if I'm like, racing through these, that you have to go at the same speed I am. This is like the 5th video I've made for this one because I keep making dumb mistakes. So I know where all this is going. Anyway, so what I need to do now is I need to replace that x in terms of u. That x is now u plus 1 over 2 minus 1 over u squared plus 2 du. 1/2 du, sorry. Yeah, I almost finished this video once, but then I realized I forgot that 1/2 when I did the u substitution, so it was bad enough. It was bad enough throughout the video that I had to go back and redo it. So I'm going to pull out the 1/2. In front of the du. And now in this numerator here, I'm also going to pull out that 1/2. And this is why I have a 1/4 here. I'm pulling a 1/2 from the numerator. So if I pull a 1/2 out of there, the first term is just u plus 1. If I pull a 1/2 out of 1, that leaves me with 2. Because I have to multiply 2 by 1/2 to get 1. This is divided by u squared plus 2. So let that sink in for a minute, I had to, I think the hardest thing seeing is why that's at 2. The reason being why, if you distributed a 1/2 in there, you would get u plus 1 over 2. And then 2 times 1/2 is 1. So that's why that's at 2 there. Dividing by 1/2 is the same thing as multiplying by 2. Okay, so let's see what we're left with. This is x plus 1/4, the integral u minus 1 over u squared plus 2 du. Okay, so now this is of the form that we had last time. It's something over u squared plus 2, so I know how to do this. Sorry, it's supposed to be an equal sign. So this is 1/4, and now I have 2 integrals here. I have the integral u over u squared plus 2 du minus the integral 1 over u squared plus 2 du. So this first integral, it's one I've been doing a bunch. I know this one. If you're not seeing it, you need to do another u substitution, use the variable v or something. This is ln of the absolute value of u squared plus 2. Again, make sure you know how to do that. Seeing me doing that is not, doesn't mean that you're going to be able to do it. On an exam, something like this, you would want to do a u substitution for and show that work. Otherwise, it looks like you just plugged it into something and wrote it down, which I'm not a big fan of. Okay, so, and then we're going to do this integral. This integral, I'm going to scroll up to the top of the page, is of this form up here. So x squared plus a squared is 2 in this case, so a is the square root of 2. So I'm just going to plug it into that formula. This is going to be 1 over the square root of 2, arctan of x over the square root of 2. And I've done my integration, so I add a plus c to the end. Last step for this is, so I'm going to go ahead and just distribute the 1/4. So this becomes 1/2 ln of, and then I'm also going to plug back in my u substitution. So u was x minus 1, so this is x minus 1 squared plus 2. You can go back up in the notes and see that. 1 over 4 root 2, arctan x minus 1 over square root of 2 plus c. So let me double check. Sorry, u was 2x minus 1, yeah. Making these dumb mistakes. It's late while I'm doing this. So that's going to be my final answer here. So unfortunately, this is the path you're going to have to take every time. If you get an irreducible quadratic, that looks like this. You will need to, do this, completing the square and U substitution every time. The good news is, this is example 6 in the book. If you get confused on what's going on, you can look at these notes. Again, the quizzes and exam are open notes, so this is available to you. So if you run across something like this, you will have a guide on how to do it, but that you will need to practice this. This is something that you need to practice to be good at. So if you have questions about any of this, this is a long example. Feel free to email me, leave a comment. I'll try to answer as quickly as possible. So I'm going to stop the video here.